Hello friends, welcome to SahuStudies. In this video, we are going to discuss about aggregate by key function in Scala. So what is aggregate by key function? So aggregate by key function is a fundamental transformation function. It is optimized and broader transformation. So whenever we are going to do any kind of a transformation on RDD, we can use aggregate by key transformation, and it is very much optimized, although it is a broader transformation. Broader transformation means shuffling of the data will be going to happen between different executors whenever you are going to use aggregate by key, but that is a very optimized function. So it is helpful if there is a requirement of aggregation and the input and output RDD are different. So there are a situation will come up when we want to perform certain kind of aggregation on a RDD, but the input and output it could be different, right? So input is in the another form, and if you want output in another form, so we can use aggregate by key function. It supports aggregations such as mean, max, average, sum, etc. count. So these are the aggregation most of the time aggregate by key function generally support. It aggregates value of each key using combine function and a neutral zero value and return different type of value for that key. What does it mean? It means that whenever we are going to apply the aggregate by key on top of a RDD, what it generally does, with the help of a combine function, it aggregates the value from each and every partition, you can see, or for each and every key. To initialize the accumulator, it generally use zero value. And when the aggregation completed, then it return a different type of value for that key. So the output could be different. Let's do an exercise which demonstrate how aggregate by key function works in Scala. So here you can see these two lines here. With the help of this import statement, I am just importing a Spark session, and with the help of this import statement, I am importing all the function. Here I am creating a list variable, and the data in this list variable are in the form of key and value, key and value, key and value. With the help of this list element, I am going to create this RDD with the help of a Spark context, with the help of a parallelize method by passing an object which has the data. So I am passing this list object which we have created here, which has the required data in the form of key and value. So whenever we are going to use aggregate function, now it takes three function as an argument. One is sequential operation function, second is AP combiner function, and third is AP zero value function. So let's discuss what this AP sequential combiner function is doing. So here what I'm just doing, I am doing a sum aggregate function. So here I'm just defining a function. In that function, I am passing two parameters. One is AP accumulator and one is AP element. And we are adding AP accumulator and AP element, and we are returning it. In second function, what I am just doing, I am creating a combiner operation. In this combiner operation, I am passing two parameters, AP accumulator 1 and AP accumulator 2. And what I am just doing, I am just adding AP accumulator 1 and AP accumulator 2. This is I am defining a variable 0 AP 0 value for sum with 0, because whenever we are going to use the aggregate by key, it will going to initialize the accumulator for each key with 0. Now what I'm just doing, on top of this RDD, I am calling this map function, and in this map function I am passing these two values. And what I'm just doing, I am just returning by fetching the value which is present in ap.value underscore 1 and ap.value underscore 2. So most of the time, no, so this is the ap underscore value is nothing but the key, this one, and ap underscore ap value dot underscore 2, this is the value. So key and value, we have stored the data into the list in the key and value pair. So here we are just getting it and returning key and value from this RDD. On top of that, what I'm just doing, I'm just calling this aggregate by key function, and we are initializing the aggregation, or we can say we are initializing the accumulator for each and every key with the 0 value. And this is the first function which I am calling. This is nothing but sequential, which we have defined here, and another is the combine operation for this function we have defined here. And once this aggregate by function completed, it 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 just put all the values in this RDD, and here we are just printing the RDD. So what here it is doing? So with the help of a map function, we are fetching what is the key and the value from this RDD, and on top of that we are performing the we are calling the aggregate by key. So it will going to do the aggregation, or first it will divide the data into a different partition based on the key, and on the each key it will going to call these two function. In these two function, the aggregation will going to happen, the sum aggregation will going to happen on per key level. So let's do this exercise on Databricks, and based on the output what it will going to generate, you can able to understand how this aggregate function generally works in Scala. So let's go to the Databricks. Let me create a notebook. Rename the notebook as aggregate by key function. Let me make it little bit, no, it's okay. So to perform exercise with the help of aggregate by key, we need some data. So I have just created a list which has the data in the form of key and value. Let me define this list variable. This list variable has been successfully defined. Let's import all the required libraries. org.apache.spark.sql, and in SQL what we are just importing, we are importing Spark session. Now let's import the required function dot apache dot spark dot sql dot, we are importing all the functions. Let me define a RDD, or let me create a RDD with the help of a spark context dot parallelize function, and pass the object which has the data. So this is the list object which we have created, which has the data in the form of key and value. This RDD has been created successfully. Now let's do a sum aggregation, right? And to do any kind of aggregation in the aggregate by key, we need to define couple of functions. So let's define the function AP sequential operation for and it's going to take two parameters. One is AP accumulator, which is a type of int. Second is AP element, which is type of int. And here, what I'm just doing, I am adding this accumulator and element. You can see here, I am doing nothing but adding accumulator and element. Run it. Okay, this has been created successfully. Means this function has been created successfully. Let's define another function, AP combiner operation for sum, and it's also taking two arguments. One is AP accumulator 1, which is of type int, and AP accumulator 2, which is also a type of int. And in the body part, what I'm just doing, I'm just adding accumulator 1 with accumulator 2. Run it. Okay, so both the function has been created successfully. Now let's define a variable AP 0 value for sum with 0. Now what I'm just doing, on top of this RDD, let's first create a value AP aggregate by key sum RDD. On top of this RDD, I'm just calling this map function. In this map, I am passing AP value and what I'm just returning here. We are calling the map, and what I'm just returning, I'm going to return AP dot underscore 1 and AP value dot underscore 2. And on top of that, I am just calling aggregate by key. And in the aggregate by key, I am initializing the accumulator with this non-zero value. This is the first parameter. Second parameter is we are doing the sequential operation. And the third parameter is combiner operation. Let's run it. Okay. What the mistake I made here? This, I think it should not be there. Error missing method aggregate by key in class pair RDD. Okay. I think this AP0 value, no, it will be it will going to initialize the accumulator. So this is the in the different bracket, and here it would be the different bracket. Now it will work. Now, okay. So let me just print, and then we'll discuss the output. Collect dot for each print ln. Let's discuss first. So what I'm just doing, I'm just taking this RDD, and with the help of map function, I am fetching the key and the value. Because the data is stored in the key and the value pair, we can see here the data is in the key and the value pair. So I am just getting it key and value pair with the help of this map function. When the key and value pair is able to identify, or we can able to get it with the help of this map function from this RDD. On top of that RDD, we are going to create aggregate by key, and here with the help of this variable, we are initializing the accumulator for each and every key, and we are passing to a function. One is sequential function and one is combiner function, which we have defined here. And once this aggregate function completed, so the sum aggregate is doing the aggregation based on the each key and store the data in this RDD. And when we are going to print this RDD, we can able to figure it out that this IT has total value 104, management has total value 13, marketing has 303, and operation has 204. Let's go to the PPT. Now this here what we are doing, we are doing the same thing, right? But we are just fetching the minimum value. So here we are just defining this. We have already done it. Let's discuss from here. This is the sequential operation, and we are passing AP accumulator and AP element. It is saying that if AP accumulator is less than AP element, then return AP accumulator, otherwise return AP element. Here also this combiner operation, here is passing two parameter. One is AP accumulator 1, and here is AP accumulator 2. And if AP accumulator is less than AP accumulator 2, then return AP accumulator 1, else return AP accumulator 2. And here we are just defining the non-zero value. With the help of a map function, we are fetching the key and value here from this RDD. And on top of the RDD, which is getting created with the help of this map function, on top of that RDD, I am just calling this aggregate by key function and initializing the accumulator with the help of a 0. And we are also passing this sequential operation and the combiner operation. Since we are initializing the value of the accumulator for each and every key with the 0 value, that's why we can see the minimum value for each and every key is 0, because we are adding 0 in for each and every key. That's why it is giving us 0. So this exercise no need to do, because this I am going to demonstrate to if you are trying to fill the minimum value, the minimum value will be 0 only, because we have initialized the accumulator for each and every key with 0 value. That's why, and no values here in this exercise. 0 is the minimum value. Now let's go to the next. Now here what we are doing, we are just doing the max aggregation, right? Here we are doing the max aggregation, and here what we are in the sequential operation, what we are just doing, we are passing two parameters, AP accumulator and AP element. If AP accumulator is greater than AP element, then return AP accumulator, otherwise return AP element. Here in the combiner operation, what we are just doing, we are passing two parameter, AP accumulator 1 and AP accumulator 2. Here what we are just checking, if AP accumulator is greater than 1, AP accumulator 1 is greater than AP accumulator 2, then return AP accumulator, else return AP accumulator 2. Here what we are just doing, here we are just initializing a non-zero variable. On top of this RDD, with the help of a map function, we are fetching, what the value we are fetching? We are fetching key and value, because the data is stored in the key and value pair. Key and value, key and value. Once the key value is fetched and it's created a new RDD. On the top of that RDD, I am just calling aggregate by key, and we are initializing each accumulator with the help of a 0. And on top of that, I am just calling these two functions which I have defined. One is the sequential function and another is combiner operation function which we have defined here. And it will going to see the value in each and every key, and it will return the maximum value for each and every key and store in this RDD. Once we are going to print the RDD, the output will look like this. IT 100 is the maximum value, management 10 is the maximum value, marketing 3 is the maximum value, and operation 200 is the maximum value. We can able to figure out from here also. This IT 100 is the maximum value, management 10 is the maximum value, operation 200 is the maximum value, and in the marketing 300 is the maximum value. Now let's do this maximum aggregation exercise now in our Databricks. So let me create functions for max. So let me just copy it. It will going to save time. I will change the name of the function. This is max. Let me put this. This is for sum. Let me put it in max. So here what we are just saying, accumulator. We can see here, if accumulator is greater than AP element, then return AP accumulator, else return AP element. Run it. Okay, this function has been defined successfully. Let's copy the another function. This is the combiner function. Let me rename it max. And here what we are saying, if accumulator 1 is greater than accumulator 2, then return accumulator 1, else return accumulator 2. Run it. Okay, now let's create a variable AP. Let me copy it from here, right? And here it would be max. So on top of AP RDD, we are going to create the map. We are calling the map function. Here we are passing map value, and we are returning two things. One is key and another is value. And on top of that, we are calling aggregate by key. And in the aggregate by key, we are initializing the accumulator with the help of this non-zero value, which we have defined. Let me define a non-zero value for max as well. Okay, it has been defined. So let me initialize the accumulator for each and every key with the help of this non-zero value, and let's pass these two function. One is accumulator function for max, and another is combiner function for max. Let's run it. Okay, this RDD has been created successfully. Now let's print it. Collect. On top of that, call for each and do print ln. Let's understand the code first. So on top of this RDD, on the help of map function, we are fetching the key and value and storing in RDD. On top of that RDD, I am just calling this aggregate by key function, and for each partition or for each key, we are initializing the accumulator with the help of a zero value, and here we are saying that for each and every partition, whatever the maximum value, just fetch it and store in this RDD. How the maximum value is going to fetch or decide, it would be decided based on these two functions which we have created. And once we have just printed, so how we are going to print? First we are calling the collect function on top of this RDD. It will going to convert this RDD into an array object, and on top of that we are calling the for each function to print each and every element which is present in this array. Okay, so in the IT, the maximum value is 100, management maximum value is 10, and for the marketing maximum value is 300, and for the operation maximum value is 200. So hence you can see in this exercise what we have done. We have seen how we can use aggregate by key function in Scala, and how we can do some kind of a aggregation such as sum, mean and max, which we have seen in this exercise, how we can do a mean aggregation, max aggregation and minimum aggregation with the help of a aggregate by key. Let's go to the PPT. Thank you. If you like content of my video, then please subscribe my channel, like it, comment on it and press the bell icon to get notification whenever I add videos.